Hello students, in this class we shall discuss AC voltage applied to a capacitor. That means what will be the current when an AC voltage is applied to a capacitor. So as usual, this is our AC voltage, that is V naught sin omega t, and I is the resulting current. Okay. We also know that for capacitor, C is equal to Q by V, that is voltage across the capacitor. This implies V is equal to Q by C. Voltage across the capacitor is equal to charge possessed by the capacitor by its capacitance value. So let us first apply this the Kirchhoff's loop rule here, that is epsilon minus V is equal to 0, that is voltage across the capacitor. So what is V? Minus Q by C equals to 0, implies epsilon value is V naught sin omega t is equal to Q by C. Now differentiate both sides with respect to time. So d by dt of V naught sin omega t is equal to d by dt of Q by C. Okay. This implies V naught is constant, so take it outside. Sin omega t derivative is cos omega t into omega. So I will write omega here. V naught omega cos omega t. This is equal to C is constant, so take it outside. Now dq by dt is equal to dq by dt is nothing but current. So I by C. This implies I is equal to, transfer C to this side. So it will be omega C V naught cos omega t. Now since voltage is in sine term, so I have to also replace this with sine term also. This is equal to omega C V naught sin omega t can also be written as cos omega t can also be written as sin omega t plus pi by 2. Okay. Now I is equal to, final expression, this term can also be written as I naught sin omega t plus pi by 2. Now this is complete current expression for the circuit. Okay. Now what is the observation here? So what are the observations? Observation 1 is I naught. I naught is nothing but omega c V naught. I can also write it as V naught by 1 by omega c. This is equal to V naught by xc, where xc is called capacitive reactance. Hello. That means this is equal to 1 by omega c. Now you must be thinking what should be its unit. Always remember, this is current, this is voltage. That means this should be equivalent to a resistance. That means its unit will be also equal to resistance unit, that is ohm. Okay, unit of reactance, whether it is inductive reactance or capacitive reactance, its unit is ohm. And it was first observation. Then what is second observation? Here you look. Our voltage was sin omega t. Now it is omega t plus pi by 2. That means it is ahead of the voltage phasor. Its phasor is ahead of the voltage with 90 degree. Okay, or it leads the voltage with a phase of 90 degree. So let us go for the waveform as well as phasor diagram, both from this expression. So first we shall go for the phasor diagram. Let us see how the phasor diagram will be. Now you see, let us first draw the voltage phasor. This is the voltage phasor. Now this is voltage phasor, so I can simply write it here V. It is always making angle omega t. Now come to the current phasor. It was V naught sin omega t. Now it is I naught sin omega t plus pi by 2. Sin omega t here, but plus pi by 2 means I have to go ahead. So current phasor will be along this path, that is 90 degree to this V naught. This length is V naught and this length is I naught. This is V naught, this is I naught. So this is the phasor diagram for our capacitor. So the difference from the inductor is that in case of inductor the current was lagging behind the voltage by 90 degree, but in this case the current is leading the voltage by 90 degree phase. Okay. Now come to the waveform. How to draw the waveform? Okay. Now you see, let us first draw the voltage waveform. Okay. This is V naught. Now this is pi by 2, pi 3 pi by 2, 2 pi. Now this is 5 pi by 2. Here current is ahead of voltage. That means voltage starts from here, current should start from here, 90 degree ahead of voltage. That means when voltage is starting here, already current is at its top point or peak point. So I will start here. Okay, for your clear understanding, I will start from here. This is minus pi by 2. So if current goes like this, it will go like this, go like this. Okay, this is the current waveform, and this amplitude is I naught. Okay, this is the waveform for voltage and current. So much for this class. In the next class we shall discuss the rest part of the inductor. Okay, thank you.